Section 9.4 hypothesis tests for one population mean when sigma population standard deviation, which is sigma, is known to us. It's a continuation of the previous two sections. In the previous two sections, we introduced the p-value test or the p-value approach and the classical method, I call it the classical method. And in both of them, we notice how to approach the problem. All of this is to test the hypothesis. Do we reject the null hypothesis or not? That's the whole idea. So in here, just we recall what we covered last in the previous sections. This test here we introduce here is called one mean z test, or some people call it the z test. Okay, so or the z test, just the z test. Okay, so there's many ways or many names to call this, or some people call it one sample z test, one sample or variable z test. Okay, to perform the hypothesis for the population mean mu, how do we perform this? First, we make sure that the sample is simple random sampling. It's coming from a population that is normally distributed, or the sample is a large sample, means the sample size is bigger than or equal to 30. And sigma here is known to us. Sigma is known to us. I'll come back to this in a minute. What we need to do is we need to make sure that when are we allowed to use the z-test or the one mean z-test. For small samples like less than 30, if the sample size say 15, the z-test should be used only when the variable under consideration is normally distributed or very close to being so. If it's normally distributed, means you have the curve is normally like bell-shaped this way, symmetric. That's if the sample size is less than 30. So that's if it's any number less than 30. We need to make sure that this sample is coming from a population that is normally distributed in order for us to use the z-test. Or another option, for samples of okay size, like more than 30, like 15, somehow close somewhere to the 30, that the z-test can be used unless the data contain an outliers for the variable under the consideration is far from being normally distributed. So you can still use it assuming there's no outliers. For the large sample, say 30 or more, the z-test can always be used with no restrictions. However, if there is an outlier are presented, so their removal is not justified, you should perform the hypothesis test once with the outlier and once without them to see what effect the outlier has. So basically you have to run two different testing. One, you try to remove the outlier out and then run a testing, and the second one is run a testing while the outlier is there and see if there's a big difference or not in the result. So these are the important things, especially the first two conditions or the first two cases. And you can read through the last two cases again and see when are we allowed to use the one mean z-test. More importantly here is how to run the test. There are two ways, either the classical approach or the critical value approach, we call it, or the p-value approach. Before we do this, we need to set the hypotheses. There are three cases that could happen. If this one is always set, no matter, for any given example, it's the same thing. If it's two-tailed test, that's the alternative hypothesis, then the mu does not equal mu0. Left you do less, bigger you do right. Decide on the significance level. That one is always given to us, so they will give this to us all the time. And then we need to compute. They wrote z here. I usually call it z sub 0. Yeah, it says here z sub 0. This is the test statistic value. If we need to use the critical value approach, what we do, we find it depends if it's a left tail test, right tail test, or two tail test. For two tail test, we need to find z sub alpha over 2, which is here. For the other ones, we just find z sub alpha or negative z sub alpha. And how do we find this out? Just to recall from before, to find z sub alpha, we go to table 2, the z table, and find the number alpha in the body of the table to get its corresponding z-value. Okay, to get its corresponding z-value. And from there, what happens is, if the value of the test statistic, if z0, falls in the rejection region, means if we have a right tail test and this is z sub alpha, okay, and then you found z sub 0, if it falls in here, then that's called rejection region. We reject the null hypothesis. If it falls somewhere here, we do not reject the null hypothesis. Same thing works for the other ones. If it falls in here, that's the rejection region. We reject the null hypothesis. If z sub 0 falls in here, we do not reject the null hypothesis. Same thing with the one on the left side. That's the first procedure, or the first test that we can use, is the critical value approach. The next one is the p-value approach. What we need to do is find the p-value. What is the p-value? Is the probability, basically. So the p-value is the probability that z is, depending on the case, like if it's z bigger than or z less than z sub 0. If depending on the case, for the left tail test, you just find p of z less than z sub 0 and use table 2. Use table 2 to find the probability that corresponds to that z value. If it's right-tailed, the probability that z bigger than z sub 0 is going to be 1 minus the probability z less than z0, or less than or equal. And then from there, use table 2 to finish it up. If it's two-tail test, it was going to be, the p-value will be twice the probability that z is bigger than the opposite value of z sub 0. And the way we finish this up, it's 2 times 1 minus the probability that z is less than or equal z0. That's how we finish it up. And then we use table 2 and get the value from there. This is really important to know how to use it. I'm gonna apply some examples or show you some examples on this. Let's say there's no word problems. They give us straightforward. The mean is 16, the sample size 37, standard deviation 9, H0 and mu is 21, H1 or HA, the alternative hypothesis, the mu is less than 21. We need to use the one mean z-test to perform hypothesis testing at 1% level of confidence. So what do we need to do here? This is alpha, actually. Alpha is 1%. So it's 0.01. Less than means it tells us it's a left tail test. So what do? We find z sub 0 here. I'm going to show you using the p-value method. So that's x bar minus mu 0 over the standard deviation over the square root of n. X bar is given 16, mu 0 or mu is 21, so that's the same here. 21 divided by the standard deviation 9, this is 37. So if we find this out, it gives me negative 3.38 rounded to 2 decimal places. Now I want to find the p-value. The p-value, it's the probability that z less than z0, which is okay to keep it like that because it's left tail test, less than negative 3.38. And now you need to go to the table 2. Looking in table 2, we find in the body of the table the probability or the area that corresponds to this z value. It's going to be 0.004. If you were asked to round to 3 decimal places, it would be 0.000. It's just simply 0. Now what do we do to see if we reject the null hypothesis? We compare the p-value. So the p-value is 0 comparing to alpha, it's less than 1%. So we reject the null hypothesis. Always, when we reject the null hypothesis, we say there is sufficient evidence. There is sufficient evidence to support the claim HA. That's an example. We can go over another example. Say at level of significance is 5%, means 0.05. The mean is 40. N is 28. Standard deviation is 4. H0, mu0 equals 39. Mu or mu0, they're the same. HA or H1, mu0 does not equal 39. So we need to test the null hypothesis. What we do here, the does not equal, this tells us it's a two-tailed test. Two-tailed test. What we need to do, always find. Notice, I mean, this is the sample size is big enough, so that's why we can use this test, the one mean z test or the z test. We find z0, it's x bar minus mu divided by this over the square root of n. X bar is 40, the mean is 39, this is 4, square root of n is 28, and I calculated this and I got 1.32 rounded to 2 decimal places. Then we're going to find the p-value. The p-value is 2 times p. The probability z is less than the not less than, bigger than the absolute value of z0, and this is the same as the 2 times the probability z is bigger than 1.32, the one I found earlier. But the table 2 only gives you to the left of z0, so we do by complementary 1 minus the probability z less than 1.32. Then this is 2 times 1 minus 0.9066, and that would give us 2 times 0.0934, and this gives us 0.1868. That's the p-value. Now we compare the p-value 0.1868. We compare it to the level of significance alpha. Alpha was 5%, which is 0.05. So it's definitely bigger. Since the p-value is bigger than the level of significance, we fail to reject the null hypothesis. So there's no enough evidence to reject the null hypothesis. No enough evidence. So now what about if we would like to work on something different? Let's say I want to do the same thing, using the critical value method. To do so, we already have z sub 0. We found z sub 0. It was 1.32. What we need to do is to find z sub alpha, actually alpha over 2. Alpha over 2. So alpha was 0.05 divided by 2. Z of 0.025. Now, what we need to do is to find this. We go to table 2, look in the body of the table for this value. That's the area. This is in the body of the table. And then I found out it's 1.96. Don't worry if it's negative or positive, because the negative, one of it is going to go. It's a two-tailed test. So the positive would be here, 0, and the negative would be here. So it doesn't matter. This shaded region is called the rejection region or the critical region. If z sub 0 falls in either one of them, then we reject null hypothesis. But what is z sub 0? It's 1.32. So it's somewhere here. That's where z sub 0 is. So we say since z sub 0 doesn't fall in the critical region, critical or rejection region, since it doesn't fall in the critical region, we fail to reject the null hypothesis H sub 0. We fail to reject null hypothesis. One thing to keep in mind, some terms like more than within the word problem, or greater than, or exceeds, like these terms, that means it's bigger than, it means it's a right tail test. If they say less than, or like fewer than, or no more than, all these means less than. This means it's a left tail test. And if they say does not equal to or different, it means it's a two tail test. So in summary, this section talks about two different ways of approaching testing the hypothesis, either using the critical approach or the p-value approach. And in either case, you should get the same answer. You can use either one of them, but you will get the same answer all the time. That's what this section